Hi, here is my solution to problem 3C from tutorial 8. So I'm going to record a few different approaches to do it, and my first approach is going to be to use the limit comparison test to figure out whether the given series converges or diverges, right? But in any case, in comparison test and in limit comparison test, so the hardest part is to figure out which series we need to compare ours to figure out whether it converges and diverges. And here we can argue as follows. We can think of, okay, so in the numerator n plus 1, n is a large number since basically n approaches in infinity, and 1 is negligible next to n, and in the denominator plus 2 is negligible next to n squared, right? So the whole thing is approximately equal to square root of n divided by n squared, so which is 1 over square root n. So which means that if we compare our series to the summation of 1 over n, then um, probably we will succeed, right? So if our series is an and this summation of 1 over square root n is bn. So let us figure out what is going to be the limit as n goes to infinity of an divided by bn, right? So which is the limit as n goes to infinity of square root of n plus 1 over n squared plus 2. So now I have just copied my original series divided by 1 over square root n, so which is the series that we are comparing it with. Now, to divide by the reciprocal is the same as to multiply by square root n. So now I'm going to simplify it a little bit. N times n plus 1 is n squared plus n divided by n squared plus 2. Well, and in order to find the limit, I just need to divide by the largest term in both numerator and denominator, which is n squared, right? So it is a legal operation to divide both numerator and denominator of a fraction by the same number. So this is going to be the limit as n goes to infinity of square root of 1 plus 1 over n divided by 1 plus 2 over n squared, which is 1, right? Since the limit is a positive number, is not 0 and it's not infinity, so we conclude that the original series converges if and only if the other series that we are comparing it with does. And we know that the series, the summation from 1 to infinity of 1 over square root n, this series diverges. Since this is a p series, where p is less than 1 as a p series. P. So p is 1/2, which is less than 1. And since this summation of bn diverges, so does the original series. So we conclude that our series diverges.